You are welcome back. Let's take a quick look at this circuit, which contains a 30 volts battery, 5 resistors R1 to R5, with resistances labeled as shown. And now from the circuit, we are required to calculate the total resistance in the circuit, determine the current flow through R3, and determine the voltage drop across R2. And now a question says, if resistors R1, R2, R3, R4, and R5 are lamps with similar efficiencies, which of them will glow brightest? So let's move to the first question that says we should calculate the total resistance in the circuit. So to approach this, we'll ignore the battery in the circuit and just focus on all the resistors. So now before a quick thing to do is to determine which resistors are in series and which ones are in parallel. Resistors that are in series are known to have the same current flow, while those in parallel are known to have the same potential drop across them. Now let's imagine our current flow to be like fluid flow, flowing in this direction. Whatsoever flows through R1 will flow through R2. That means R1 and R2 are in series. But when it gets to this junction, it splits into two. So that means that R3 and R4 are in parallel because the current that flows through R3 is not the same as that flows through R4. So the current that flows through R3 combines with that through R4 and continues in this manner. So it's common sense to say that the current that flows through R1 and R2 will flow through R5. And the current that flows through R1 or R2 will be the current that will flow through R3 plus the current that will flow through R4. So now let's add them up together. For resistors in series, so the R total here, the total resistance R total should be equal to the resistors in series. You just add R1 to R2 plus R3 in parallel with R4 plus R5. So what this means is that R1 is in series with R2, in series with R3 and R4, and in series with R5. So R3 and R4 are in parallel, which we'll treat especially as resistors in parallel. So let's fix in the values for R1 to R5, which is R1 is 3.8 ohms plus 6 ohms for R2 plus for R3 and R4, we would do something like this: 1 over R3, which is 1 over 8, plus 1 over R4, which is 1 over 12. I haven't done that. We'll find the inverse. We'll raise to power minus 1. Then plus R5. R5 is 5 ohms. So simplifying, 3.8 plus 6 plus 5. Okay, let's just go ahead and say this 3.8 plus 6 plus finding the LCM of 8 and 12. Simplifying, we should get 4.8. Sorry, I forgot to put the units here. Ohms plus 5, all ohms. So when we add this together, we have a total of 19.6 ohms. So the only aspect here that is not completely straightforward is where we looked at R3 and R4. And that's where we said resistors R3 and R4 in parallel, which should be 1 over R3, 4 is equal to 1 over 8 plus 1 over 12. We go through LCM or excuse me, you can say let this be 96. 8 into 96 is 12. And 12 into 96 is 8. That gives us 20 over 96. So then that means that R, we'll find the inverse. We know this is 1 over R34. Then we return to say, then what is R34? That will be equal to 96 over 20. So when you simplify this further, you get 4 over 8. So the solution to this question is to say that the total resistance in the circuit is 19.6 ohms. Let's move on to the next question that says that determine the current flow through R3. So from the previous question, we have determined the total resistance to be 19.6 ohms. So we can just put that here. R total is equal to 19.6 ohms. What that tells us is that we can have a similar circuit having a battery 30 volts and a single resistor 19.6 ohms. And so these two circuits, they are equivalent in the sense that the current that will flow out of the 30 volts battery here will be the same. Since every resistor here, these 5 resistors can be replaced with a single 19.6 ohm resistor, then the same current that will flow through out of this 30 volts battery will be that which will flow out of the second 30 volts battery. So we need to determine what is the current that will flow out of the battery. The current that will flow out of the battery is defined current I is equal to V over R, remembering our Ohm's law, which has always been V equals to IR. Then I equal to V over R. Current I is equal to V over R. And the V here is 30 volts, while the R here is 19.6 ohms. And that gives us 1.53 amperes. So that means that 1.53 amperes will flow out of the 30 volts battery. 1.53 amperes will flow out of the 30 volts battery. 1.53 amperes will flow through R1. 1.53 amperes will flow through R2. The 1.53 amperes will split into 2. Not equal out, but it will split into 2. Some will go through 8 ohm resistors, the others will go through the 12 ohm resistor, and they will meet at this junction and add up to 1.53 amperes, and 1.53 amperes will flow through R5. it is easy to imagine that when 1.53 amperes gets to this junction, the bigger fraction of the 1.53 will flow through 8 ohms because it poses a lower resistance compared to 12 ohms. So more current will flow through 8 ohm resistor than what would flow through the 12 ohm resistor. And the two, and both would meet at this junction and we'll continue. So there are different ways with which we can approach the ways with which we can determine what will be the current that will flow through R3. So now we know that the current that flows through R1, R2, and R5 is 1.53 amperes. Since we know that, we can also determine what will be the voltage drop across each of these resistors. The voltage drop across R1 will be 1.53 amperes times 3.8 ohms. So that's like saying the voltage that will drop across R1, you can say it is, let me use another color, you can say it is V1 is equal to I R1, and that is equal to 1.53 times R1, which is 3.8 ohms. Similarly, the voltage that will drop across V3 and V4 will be equal to this same current. You can say I3, 4 times R3, 4. So the voltage that will drop across resistors 3 and 4 is equal to the current that will flow through resistors 3 and 4 times the total resistance of resistors 3 and 4. And that will lead us to saying that the total current that flows through resistors 3 and 4 is still 1.53, while the total resistance between resistors 3 and 4, which are in parallel, that we learned from the previous question, is 4.8 ohms. So without wasting time, we can just take that value of saying the total resistance for resistors 3 and 4 is 4.8 ohms, and say this is 1.53 amperes times 4.8 ohms. So amperes times ohms give us voltage. Hence, we can easily say that 1.53 times 4.8 will give us 7.34 volts. So, excuse me, please. So 7.34 volts is dropping across resistors R3 and R4. What that means is that if I wire up this circuit above and I place one lead of my voltmeter at this point and the other lead here, it should read 7.34 volts. Just like we got when we were doing across R1, which is 1.35 times 3.8, we can calculate for each of these resistors and eventually add them up to give us 30 volts. So the voltage drop across R1 plus voltage drop across R2 plus 7.34 volts plus the voltage drop across R5 should add up to 30 volts. Excuse me. So now let's since we know the voltage drop across R3 and R4, better still, we can say the voltage drop across R3 is 7.34 volts. Since the voltage drop across R3 is 7.34 volts, then the current that will flow through R3 will be I3. Let's get another pen. We're talking about I3 will be equal to the voltage drop across R3 and R4 divided by R3, and that is equal to 7.34 divided by R3, which is 8 ohms, and that is equal to 0. Okay, this is volts over ohms, and that is equal to 0.92 ampere. So the current that flows through R3 is 0.92 ampere. And this is the solution to the problem that is provided. If we want to determine what will be the current that will flow through R4, we have two options. The first option is to apply Ohm's law and say the current that will flow through R4 should be voltage across R4 divided by R4, and that will be 7.34 volts divided by 12 ohms, and that will give us the current that will flow through R4, which would actually be a smaller value compared to 0.92. But the most important point you should notice that the current, whatsoever you calculate as the current that flows through R4, which is 7.34 divided by 12, when you add it to 0.92, you should get 1.53, which is the current that should flow through R1, R2, R5. Okay, let's move forward. Now we have a question here that is saying, what is the determine the voltage drop across R2? The voltage drop across R2, let's define that to be V2. The voltage drop across R2, let's define that as V2, and V2 can be called I, which is the current that will flow through R2 times R2. So what is the current that flows through R2? We have determined that earlier by saying 1.53 amperes flow through R1, flows through R2. Then our high here is 1.53 amperes. Let me look at the ampere. So V2 is equal to 1.53 times R2, which is 6 ohms. So 1.53 amperes times 6 ohms will now give us a V2 that is 9.18 volts. What that is telling us is that across R2, when you place your voltmeter across R2, we should measure a voltage of 9.18. When we placed across R3 and R4 earlier, we measured the voltage across R3 and R4 area, we measured 7.34. What that is telling us is that the voltage across R1, when we add it to the voltage across R5, it should give us 30 minus 9.18 minus 7.34 should give us the voltage across R1, that is V1, plus V5. So you can determine the voltage across V1, across R1, which you can describe as V1, and the voltage across R5, which is V5, by simply saying R1 is equal to I, which is 1.53 times 3.8. And for V5, the current that flows 1.53 times 5. So with that, you can determine your, so whatsoever you, so 1.53 times 8, sorry, 1.53 times 3.8 plus 1.53 times 5 should be equal to 30 minus 9.18 minus 7.34. You can play with it. I'm very sure 100%, if not even more than that, that this equation will be balanced. So now we've determined the voltage drop across R2 to be 9.18 volts. And the last question says, if resistors R1, R2, R3, R4, R5 are lamps with similar efficiencies, which of them will glow brightest? The one that will glow brightest will be the one that will be dissipating the largest power. So what that means is that we need to calculate the power dissipated by each of these resistors. We need to determine the power dissipated by each of these resistors. And to determine the power dissipated by each of these resistors, we know their resistances, and we know the current flow through each of them. We know that the current flow. So we can do something like let's do something like a table. Let's say we are the currents and resistance. So for R1, R2, R3, R4, and R5. I hope this is big enough. So the current that flows through R1, we know it as 1.53 amperes. The current that flows through R2, we know it as 1.53 amperes. The current that flows through R3, we determine that to be 0.92 amperes. The current that flows through R4, that should be 1.53 minus 0.92, that should be 0.61 ampere. That is 1.53 minus 0.92 should give us 0.61 ampere. the current that flows through R5 is still 1.53 amperes because R1, R2, and R5 are in series with R3 and R4 merged as being in parallel. So now the resistors of each of these resistors is for R1 is 3.8 ohms. So let me just put ampere here. And let me put ohm here so that I don't have to be writing units all the time. R2 is 6 ohms. R3 is 8 ohms. R4 is 12 ohms. And R5 is 5 ohms. Then now, the power dissipated. Power is defined as the product of current and voltage. Since voltage is equal to IR, product of current and resistance, then power can be defined as current, since V is IR, another IR. Then you say power is equal to I square R. So power can be defined as IV, I square R, or even I think V square over R is still power. But the relevant expression we need here is to say power is equal to the product of the square of current times resistance. So to determine this, what we do is to calculate the power of each of them, which is for the first, for R1, I square, I1 square times 3.8. So 1.53 times 1.53 times 3.8. That should give me a value of about 8.90, and the unit of power is what? Watt. For R2, 1.53 times 1.53 times 6 will give me 14.05 watts. For R3, 0.92 times 0.92 times 8 will give me 6.74 watts. For R4, 0.61 times 0.61 times 12 will give me, okay, let me say it properly, 0.61 ampere times 0.61 ampere times 12 ohms will give me 4.49 watts. Okay, I've put watt upstairs. There's no need to write watt here anymore since it is here already. Then finally, for the power dissipated by R5 is 1.53 ampere times 1.53 amperes times 5 ohms will give us about 11.70 watts. So looking at all the power dissipated across the 5 resistors, the one that is dissipating the largest power is clearly R2, which is a resistor of 6 ohms carrying current 1.53. It is the brightest. And the dimmest of them all is R4, which obviously you can see is has a small current flow of 0.61. So, long story short, the brightest of all the lamps is R2. So we are in this problem, we the alarms of similar efficiencies, if they were to be speakers, R2 will be the loudest. If they were to be electric motors, R2 will be the fastest. If they were to be heaters, R2 will heat up more quickly than the other resistors or than the other heaters, rather. So these are just basic concepts which can be applied in many aspects of life, or let me say many aspects of electronics, electricity, and I wish you the best. So please let me have questions in the comment section, or better still send an email. I'll be happy to answer them. See you in the next video.